Hi, and welcome to Part 3 of Learn C for Cybersecurity. In this tutorial, I will further explain arithmetic-operators in C. If you haven't already, please take a look at Part 1. You can see the link in the blog post. In order to find this blog post, you can take a look at the link in the video description of this video. There, you will see the link to Part 1 immediately. If you haven't already done Part 2, I strongly encourage you to do Part 2 right now, before you start this tutorial. When we last left off, we were talking about basic arithmetic operators, addition, subtraction, multiplication, and modulus. In this tutorial, I will talk about assignment operators, compound operators, relational operators, conditional statements, and ternary expressions. So let's begin. Let's begin with that assignment operator. For those of you who have experience in Java and C++, you are familiar with assignment operator. You probably got really confused with the meaning of the assignment operator at first, confusing it with the equivalence symbol in math. And remember, the assignment operator always assigns a value to a variable. So in assignment.c, we have a demonstration. Take a look at the values here. A is assigned 3. B is assigned 5. Now, for those of you who know Java and C++, you probably already knew that. For those of you new to Python from another language, like, say, I don't know, Lisp, you may be a little surprised by the syntax just because of how Lisp works. In this new line over here, we have something else going on. We have multiple assignment operations in one line. What this line means is that the value of B is assigned A. Then the value of A is assigned C. So, as the comment says, read from right to left. And you can see the terminal output here. Let me go do it myself right now. So that would be the terminal output for the program specified here. To be completely honest with you, featuring assignment operators usually doesn't get much more complicated than this. I mean, as long as you understand the multi-line assignments, you're going to be good to go. So let's move on to compound assignment operators. In Part 2, I discussed the importance of PEMDAS, including the basic arithmetic operators. PEMDAS are a repeat of the order of operations you learned in middle school. So the order of operations is parentheses are evaluated first, then exponents, then multiplication and division from left to right, then addition and subtraction last. So in this code segment that you see here, I demonstrate the difference between basic arithmetic operators and the compound version. Let me go ahead and show you that here. So let's take a look at this line. We simply print out the values at first. That's normal. So what does this mean? All this means is that A is added to the value of C, and sum's result is assigned to C. That's all it means. In reality, it's really no different from C is assigned A plus C plus A, to be honest. That's it. Now that whenever you see this equal sign after a basic operator, you know that it's a compound assignment doing something similar. And the same logic follows for all of these. This means you are subtracting B from the value of C and assigning that difference to C. This means we are multiplying B to the value of C and assigning the product to C. Same logic for the rest. You should be able to follow along by now. I don't want to bore you with the details. Let me see if I can find anything here that might get extra confusing. That should be all good for you to understand from, yeah. I really don't think I need to say more than this. If you get confused by this and you still don't understand anything in the blog description, let me know. Remember, if you want to follow along with this video, please click on the link in the video description to follow along. I actually encourage you to pause the video and practice tweaking the variables A, B, and C in the code above for this file, compound versus basic assignment.c. If you were in the blog right now, you'll be able to click on the link here and be able to download the code, or you can just click on the download button right here. You'll be able to download it to your Linux machine, and you would be able to compile and execute it. You can then see the results of the operations in the terminal right here. So, strongly recommend you pause the video now to tweak those values A, B, and C, and check out how it changes the outcomes shown in the terminal. Let's move on to relational operators. So relational operators are basically the comparison operators you learned in elementary school. I mean, let's take a look at these. Less than, greater than, less than or equal to, greater than or equal to, equal, the equivalence symbol, not equal symbol. You actually should be familiar with the non-equal symbol by now from part 2, if I'm not mistaken. If not, well, here you go. To be honest, there's nothing extremely confusing about these. If you know elementary school math, the outcomes of these should be obvious to you, so I won't go further on that. I just want to remind you of one thing. Whenever you see false, remember that's represented in C as the number 0, and true is represented as the number 1. That's how C coders specify Booleans. Keep in mind, we're using Turing machines, right? So you have to use some number to represent things. In fact, every object is actually represented as a big number. That's just how it works. So here we have a demo of all these conditional statements, and there is honestly nothing really surprising to the outcomes in this file, in my honest opinion. If you're familiar with Java, C++, or Python, all of this should be familiar with you. Yeah. I even named them so that it's really obvious what they're doing, if it weren't already. And you can just download this file. Let me compile it first. You can just download this file and see the outcome below. Practice, if you're still a little confused by this, you can practice tweaking these values and trying to see if it changes any of the values here. But to be honest, I really didn't think this would be that difficult for most of you to understand, since you should already have previous programming experience. Not that the exercises aren't going to be without difficulty. They were slightly difficult even for me to solve. There are 8 exercises, if I'm not mistaken, for this tutorial. You can see them after you watch this video by clicking on the link in the video description. I can talk all day, but the truth is, if you don't do the exercises, you're not going to learn anything. So I decided to focus more on showing code this time, instead of me just literally reading through the blog post, because I thought that would be more interactive and a better use of your time. So let's move on to conditional statements. Part 2, I discussed Boolean logic and logical expressions. Boolean logical expressions are used to make yes or no decisions, as I said in part 2. So now that you've seen relational operators, I think we are now ready to see how computers actually make use of these logical expressions to make practical yes or no decisions. In part 2, we actually practice getting the machine to print a 0 if something's false and a 1 if something's true. We never actually took advantage of that to decide what the computer does in reality, other than printing the 0 or 1. So if you already know a C-based language, such as Java, C++, or Golang, you should know what these are. In a conditional statement, the computer tests if a logical expression is true. If so, it executes a block of code. If not, the computer altogether skips executing the block of code associated with the logical expression. So in this, we have an example here of that. Let me go ahead and show it to you. So we have our logical expression. I just made it extremely simple so you understand how if statements work and see if you are not familiar with them. So our logical expression is assigned 1. It's a bool. It's a type bool, so that's normal. If the if statement accepts a conditional expression, if that conditional expression inside the parentheses evaluates to a 1, then it executes the block of code inside the curly braces. If logical expression here was 0, it would altogether skip this and go and start looking at what is below. And just to make that clear, I actually wrote a second logical expression that actually was initialized to 0. So in this case, since second logical expression values to 0, it's going to skip this, skip what's in the curly braces, and move on to below. But in logical expression, it's going to actually print this statement because logical expression evaluates to 1, okay? Here is a third logical expression, and I really wrote this so that it really hits home that if the conditional expression itself is false. Actually, it's true, my bad. If the conditional expression is true, my bad, it's going to print this. My bad. Let me try that again. If in the fourth logical expression, since it's assigned to 0, I wrote this to really hit home that if the entire conditional expression evaluates to true, regardless of what the initial value of any initial conditional expressions are. If the final output of the conditional expression is a 1, as it is here, then logical not flips the 0 to a true. It will actually print this. The fourth logical expression evaluated to so on and so forth. And let me just show what it does. So we can see that the first, third, and fourth make it. The second one doesn't make it. And that's because the entire second logical expression is 0, and that's all we put in between the parentheses. Take a look at what's in between the parentheses for every if statement you find, and determine if the entire conditional expression itself evaluates altogether to 1. If it does, only then will the block of code be executed. If not, it will skip the block of code and move on to the next line below. If you're having trouble with this because it's your first time seeing conditionals in C, just pause the video and compare the above source code with the terminal output. Be mindful of the parentheses. Some languages like Python don't need that, or better yet, don't even allow it. Well, in C, they're required. Let's move on to the if-else statement. So an if statement all by itself just executes the block of code below the logical expression. If the logical expression is false, the computer skips the block of code below the conditional expression, as I said many times. But in an if-else statement, when the conditional expression is false, the computer will instead execute the block of code below the else keyword as shown below. So here, the logical expression is actually assigned 0. 0 does not equal 1, so it's just going to skip this. And instead, it's going to go straight to the else keyword. It will actually execute the block of code, which just says logical expression is false. And that's what's going to happen. Let's do it. Let's see if that happens. Oops, my bad. Here, let me redo it. Yep, like I said, logical expression is false. And that's because logical expression is 0, and here we were trying to test if logical expression was equal to 1, which it's not. Let's move on to if-else statements. So the thing about if statements, they're an extension of if-else statements. Let me go ahead and open the file. In principle, you can have an if statement here. You can then have an infinite number of else-if statements between the first if statement and the final else statement, just to let you know. But to be honest, else-if between the first if and the last else is optional. It's not required. So like I said, you can have as little as 0 else-if statements between the first if and the final else. You can have as many as infinity else-if statements between the first if and the last else. In this case, we are testing if the following conditionals is true. We are testing the sign of INTA, which is -1. Now, since it's -1, this is going to be false. That's just common sense. -1 is not greater than 0. It's not equal to 0, so it's going to skip past this. So it hits else, and where it prints A is less than 0. That's what happens. Let me go ahead and compile this for you. Yep, A is less than 0, as it truly is. If-else-if statements are very important in helping computers make yes or no decisions. When you have complex logic, you'll see them a lot. So I encourage you to get used to if-else-if statements. A great website to really test your Boolean logic skills is codingbat.com. However, it's a pity that the website only supports Java and Python. Nonetheless, since this course already expects you to know Java and C++, I would expect the Java, Java, and C++ coders to already know what I just said. I was just giving a recap. In an if-else-if-else statement, only the first conditional statement that evaluates to true will have its block of code executed. I even named this file to hit that part home. Only the first true conditional is executed. Let me go open that. So we have A is assigned 5. We are testing the sign of A again. And the thing is, since A is assigned 5, this is false. A equals 5 is false as well. A is greater than 0 is true. And it prints this. Oh, wait, my bad. I messed up. A is assigned 5, so A is less than 0. My bad. That's false. 5 is not less than 0, so it skips that. A equals 5. So it's going to print A equals 5. It will never actually look at A is greater than 0, even though that's technically true. And let me repeat that again. Since A equals 5, and that's the first conditional statement that evaluates to true, this block of code will get executed first. And the machine will stop right there. It won't consider any of the else if or even the else statement below that, okay? And I will compile this to demonstrate that. There we go. A equals 5. Look at the code. We see that we command the machine to print A equals 5 if A equals 5 is true. Let me go ahead and check if there are any extra notes I should say. Nope, I think we're good. Let's move on to switch statements. So switch statements are best used when the machine must examine between different possible values on a case-by-case basis to determine which block of code must be executed. The following code demonstrates the use of a switch statement. Let me go open this file. So we have A is assigned 3. Notice in the switch statement, we don't actually see a literal conditional expression. We literally just place the variable directly in the parentheses, and that's it. And what we see is, on a case-by-case basis, it's checking if A is equivalent to any of these numerical values directly. In an if-else-if-else statement chain, we would have to put a conditional expression. But in a switch statement, we can put a variable that has a value directly in the switch statement. Typically, switch statements aren't actually used a lot, just to let you know. They're used sometimes. Nonetheless, since I've seen switch statements used in compilers before, I decided to talk about them. So in this case, we have A is assigned 3, and that means it's going to skip past case 0, right? Because that's not what A is. It's going to skip past 1. It's going to skip past 2. A is assigned 3, right? Just double checking. Yeah, it's assigned 3. So it's going to definitely look at 3, and it's going to choose this one. It's going to print 3, and then a new line character. And then it'll stop right there because of the break. I want you to pay careful attention to the break statements. You need those to make sure that the code that the machine doesn't bleed through the first case statement evaluated. Unlike an if-else-if statement chain in a switch statement series, just because you have one case evaluated as true doesn't mean it's not going to keep going and checking the other cases. No, you need the break to actually stop that from happening. By specifying break, you guarantee that the computer will stop looking through any further cases. I'd like to talk about the default. You may have guessed this, but the default pretty much is what's evaluated in case all the above cases fail. So in this case, it's going to print 3. Let's go try it. it did it. Since A is assigned 3, it's going to skip 0, 1, 2. It's going to hit 3, then it's going to print it, and it's going to stop right there. So, similar to an if-else-if statement, the switch statements ignore the first several cases and their respective blocks of code, only executing the block of code for the case that matches. And it's a good habit to include a default case in a switch statement that detects all previous cases have failed. However, including a default case is optional for switch statements. I believe the ternary operator is the last thing I'll talk about in this lecture. If you ever get tired of using if-else statements, or if you ever want a shorthand way of doing if-else-if-else statements, a ternary operator might be a great alternative. So what is the ternary operator? If you're coming from Java, you probably don't know about this. If you're coming from C++, you may or may not know about this. But C coders have a habit of occasionally using ternary operators. And the ternary operator is denoted by this question mark symbol. So here's some sample code that demonstrates how it works. Let me go ahead and actually open the file. So I defined 2 macros, true to be 1, false is assigned 0. If you have no idea what a macro is, you need to stop watching this video and watch part 1. I'm just saying. I'm not going to explain that here. Do the exercises for part 1 too. I explain what they are in the exercise. So in this Boolean expression, since true symbolizes 1, this is a true conditional expression. When that happens, the machine will immediately evaluate the expression immediately after the ternary operator, which is 1 in this case. Since 1 is the evaluation, 1 is assigned expression. In this case, since false represents 0, the machine will skip past the first expression, keep going until it finds the colon, go past the colon, and evaluate the expression after the colon instead. In this case, that's 0, so that's what's assigned to not expression. Let's go talk about this one over here. This one's really interesting. So what's expression? Expression is technically assigned 1, like I said it would. And then since that's the case, it's going to look at the expression right after the first ternary operator, which is printf. Expression is true. It's going to print that. It's going to completely ignore this one. Expression is false. That's not going to happen. But for this line, not expression, since not expression is 0, it's going to skip past the first expression, go past the colon, and evaluate that expression instead. Not expression is false. That's what happens. I really think ternary operators are a very handy feature in C. I like using them whenever I have a brief if-else statement and I want my code to look shorter and more compact. Let me go ahead and show off the ternary operator right now for all of you. Here, let me clear the screen. And we can clearly see that all the information is printed out cleanly. Ternary operators might be new to you, and if so, I encourage you to practice using ternary expressions and statements in your code to become skilled at using them. There are 8 exercises in the blog post, which is hyperlinked in the link in the video description. So I encourage you to practice using them there, if you haven't already used them before. When you intend to make more than one comparison on a case-by-case basis, it may be better to use an if-else statement or a switch statement. All right, that's all I wanted to say for today. I try to keep this a lot shorter than usual. They are around 2, 3, 4, 5, 6, 7, 8 exercises. I need to delete that 3-0. That's not going to work. Yeah, there are 8 exercises. Oops, I showed you a little bit of solutions manual. Ha! I have fun seeing that. Yeah. If you enjoyed this video, please like, comment, subscribe, and click on bell notifications for more. And thank you for bearing with me as I show my face for the first time. All right. Peace.